Hi, welcome to Always Eclectic, Stacy. We're in our Always Eclectic chemistry series, and today we're talking about intermolecular forces and how atoms are held together. Ready, set, let's go! Today we're talking about intermolecular forces and how they react with molecules. So let's first get into what is an intermolecular force. It's shortened to IMF. So if you hear about IMFs, they're talking about intermolecular forces. And these are the forces that are holding covalent molecules together. And there are several different types of intermolecular forces. And we're going to talk about it from the weakest to the strongest. So the weakest intermolecular force is your dispersion force. And yes, dispersion forces are in every single molecule. So this force, although it is the weakest, is found in every molecule. Every molecule has at least a very, very weak dispersion force. Yes, it is an IMF. This is the dispersion force between your nonpolar compounds. It is the weakest because there's no poles, which means there's less energy to break. Then you have your dipole-dipole force. This is your intermolecular force between polar compounds. It's kind of our middle IMF. And when we're thinking about strength, you need to start asking yourselves and have the thought process, how much energy is it going to take to break the bonds? If it's not a lot of energy, it's going to be a really weak force. If it's a little more energy, it might be a medium force. If it's a lot of energy, it's going to be a strong force. And the dipole-dipole force is stronger than the dispersion force because they have positive and negative poles that are attracted to each other. So it's going to require more energy to break these bonds. And yes, the negative pole is attracted to the positive pole on the other one. So it's very much like magnets holding each other together, but not as strong as ionic. Then you have hydrogen bonds. This is your strongest intermolecular force. And a hydrogen bond is really specific. It is between a hydrogen atom and a fluorine, a hydrogen atom and an oxygen, and a hydrogen atom and a nitrogen. And that is because, and the why they're so strong and why they have a really high strength and melting point and boiling point and surface tension and molar mass, because those all get stronger and higher the stronger it is because these are very positive and very negative poles, which means it's going to take a lot of energy to break these bonds. We're then going to talk about an ionic bond, which is not an intermolecular force. This is a bond between a metal and a nonmetal, a cation and an anion, and a cation and an oxyanion. But we're talking about this because when we talk about IMFs, it's really between your covalent molecules, but an ionic bond is just fundamentally stronger than any of the covalent bonds, even the strongest covalent bond or strongest covalent IMF, which is in hydrogen bonds. That's because you need to use lattice energy to break them. So the why for all of these is how much energy does it take to break them, and this takes a ton of energy to break. Remember, the more negative the lattice energy, the stronger the ionic bond. So then we have intramolecular forces. So we have inter and intra. These are the forces holding a molecule together. These are your covalent bonds, your coordinate covalent, your polar covalent, and your nonpolar covalent. So that's just holding the molecule together versus inter, which holds a bunch of molecules together. And then when it comes to all of this, we have to talk about solubility. I know we've talked about it before, but remember, we have to understand that different things are dissolved in different things. So it's always good to remember like dissolves like. So polar, which has both a positive and also negative pole, will dissolve both polar and ionic, because they both have those two poles that'll help separate the molecules, versus nonpolar will only dissolve nonpolar. This is again why water and oil do not mix, because water is polar and oil is nonpolar. Finally, we always have to talk about water when we're talking about intermolecular forces and intramolecular forces, because the unique mixture of these inter and intramolecular forces is what gives water its unique properties and which allows life to be everywhere. These properties are primarily due to the hydrogen bonds, but not just the hydrogen bonds, because not everything with hydrogen bonds have these properties. It is also due to the Vesper shape. So it's a mixture of hydrogen bondings and the bent Vesper shape, which allows it to expand when freezing, making it less dense lattice and to float on top, which is why we actually have liquid water. It has really strong intermolecular forces. It has an incredibly high specific heat, which is the energy needed to heat 1 kilogram by 1 degree. And the boiling point is 100 degrees Celsius. This is all due to the specific IMFs needing more energy to break or disrupt the bonds. And this is just an incredible example of how intermolecular forces, intramolecular forces, and Vesper shapes can create a really cool molecule, which really allows life to flourish here on Earth. Thank you so much for listening to Always Eclectic Stacy. If you enjoyed this video, please don't forget to check out my other videos or like and subscribe. Thank you so much. Have a great day.